All right, guys, here we are. This is still section 12.2, but now we are doing 12.2 part 2. And just when you thought we were getting away from a bunch of theorems, we got a bunch more coming at you. All right, so just kind of bear with me. I should expect to see all of these in your notes. And then we'll do a quick practice problem or two at the end, and that'll be it for the section. All right, so check it out. It says if AB, let me zoom in on these guys here. If AB is the diameter, so here's AB. Actually, let's do this guy. If AB is the diameter and AB and CD are perpendicular, alrighty, then this should tell you that this guy is bisected, all right? And this also tells you that the arcs created are equal to each other. So that is theorem 12-8. Okay, again, this is probably the biggest one here, and that is if you know that this is diameter and that guy is a 90-degree angle, this side is equal to that. Okay, excuse me. 12-9, basically, if AB is a diameter and CE is equal to ED, so this is CE and ED, then there we go, is perpendicular. So again, that's basically the opposite or the converse. And then let's take a look at theorem 1210. 1210 says if AB is perpendicular, the perpendicular bisector of the chord, so here's AB. If you know it's a perpendicular, so that guy means perpendicular, bisector, those little guys there, then AB contains the center of the circle, right? There it is. There's a center. So you know that right here, there's no center marked, and usually it is if we kind of look around at all these circles here, all the way at the top, they're always marked. So in this particular case, it is not marked, and so we have AB goes all the way across. We ask ourselves, is that the center? We don't know. However, we would know, knowing that we have a perpendicular bisector, right? Perpendicular mean 90-degree angles, and those guys, two segments are equal to each other. All right, cool. Now let's do a proof. Just kidding. No proofs for you guys. Let's get rid of that dude. All right. Let's skip down to an example problem down here. So problem number 4. Basically it says, what is the value for each variable to the nearest tenth? So what does that mean, right? You can take a look at the stuff on the side. I'll just do it for you. So we are looking to find the value of R. What information do we have? We know that this guy is 14 centimeters. We know that that guy is 3 centimeters. And now we're basically looking at a right triangle, right? So we'll call this guy A, we'll call that guy B, and we'll call this guy C. Now the deal with B, though, is that we have to just recognize that B is going to be that guy right there, not the entire length across. Okay, so B is going to be 14 divided by 2, so that's 7. And we're off and running to the races here, so we're going to say 7 squared plus 3 squared equals R squared. All right, hopefully we're good with that. Sure, why not? So let's go R squared. That's 49. That's 9. We're going to get the square root of each side. I'm just going to flip that R over to this side. And 7.6. I'll do a little squiggly line for approximately. Alrighty. And another problem. We want to find the value of Y. Okay. So remember, we're given 15 here, but that is our radius. And what the heck is that guy? So the 15 is our radius. So remember, that's also our radius right there. And what we're given now is this value of 11. So we have 11 and 11. But yeah, we're good to go. Hopefully that kind of starts to make sense here a little bit. So even though R is 15, we have 11. We'll call that A. Even though we have a value of Y, we'll call that B. So even if we just kind of just said A squared plus B squared equals c squared. We'll just see that the setup's slightly different here, right? That is 11 squared. Now this is y squared and 15 squared. Okay, makes sense. Y squared. And I'm going to bring this over just like this, minus 11 squared. Throw that into your calculator. And now y is equal to, I should say approximately equal to 10 dash 2. Okay, I'm going to scroll down just a little bit and you will see it's the end of the chapter or end of the section. All right, guys, I'll see you in the next one. Take care.